Hello, everybody, and welcome to Chapter 7. We're on page 429, and we're doing the Get Ready problems. And this video is going to be in two parts. So this is going to be part 1, and then I'll have downloaded part 2 at a later time. So squaring numbers. Review. 3 squared. It's not 6. It's 3 times 3, 9. You can use a calculator. 4 squared, 4 times 4, 16. 11 squared, 11 times 11, 121. Okay, squaring numbers. Now we're looking at order of operations. So you multiply first. 2 times 7.5 is 15. Plus 2 times 11 is 22. 15 plus 22 is, I believe, 32, 37. Pi times 5 squared is 25 pi. It says you use 3.14 in your calculator. You multiply 25 times 3.14, and then you should get the answer yourself. 25 times, you actually have your pi key on your calculator. Remember, you can use that one. It's shift up EXP. It's on the bottom. This one, we're going to square the number first, and then add the 2, and then take the square root. So 5 squared is 5 times 5, plus 12 squared is 12 times 12. We add them together is 169. Square root of 169 is 13, because 13 times 13 is 169. Evaluate the expression. It means we're substituting these numbers for the letters. So A is 4, plus B is -2, all that divided by 2. 4 minus 2 is 2. 2 over 2 is 1. A is 4, take away 7. 3 minus -2. Notice this minus and this minus is not the same. You got 2 negatives. 4 take away 7 is -3. 3 plus 2, you're adding it, is 5. This one, A is 4, 7 minus 4, quantity squared, plus 2 minus -b, quantity squared. Now we use brackets. And then take the square root. 7 take away 4 is 3. 3 squared is 9. Plus 2 plus 2 is 4. 4 squared is 16. 9 plus 16 is 25. Square root of 25 is 5. Absolute value bars, this is what this means. Absolute value definition, it's the distance of this number to 0 on the number line, and a distance is always positive. 2 minus 6 is -4. The absolute value of -4 is +4. -5 plus 8. -5 plus 8 is 3. The absolute value of 3 is 3. Solving equations, let's do the hardest one. We need more practice. We had so much practice already. 2 times x is 2x. 2 times 3 is +6. Minus 1 is 7x. Subtract 2x from both sides. Line them up. 6 minus 1 is 5. 5x. Divide by 5. Cancel. X is 1. Artists often use long streaks to show rays of light coming from the sun. A ray is also a geometric figure. What do you think the properties of a ray are? Okay, a ray has a beginning and no end. It keeps going. That's what a ray is. Yeah. If you and your friend work with each other, in other words, you and your friend are co-workers together, you work together, what might be the term collinear mean in geometry? Collinear means points are on the same line. Collinear, they can be a straight line. Oops. And those words will come up in this chapter 7. So they're kind of giving you heads up. All right, next page is our beginning page. We're on 7.1. And there's a video I wanted you to watch on YouTube that I downloaded on Canvas. And I want you to watch that video. Maybe I should watch it with you right now. Let me see if I can find it. Pause this. Now, you know what? It'll take too long. I want you to watch the video, pause this right now, watch the video. There are actually 2, and you tell me which one you like better, and then come back to this, and then you understand it better, okay? So nets and drawings, pause the video for visualizing geometry. Okay, I'll wait for you to come back. All right, I hope you made the right decision. You paused and watched the videos first. So what we're learning is to make nets and drawings of 3-dimensional figures. So 3-dimension means you have depth to it. 2-dimensional is a flat surface like a paper, but now we're adding another dimension, which is the depth, yeah, 3 dimensions. And skipping problem 1, going straight to the next page, which is up here. We're on page 435. And you're matching the figure with its net. So if you watch the video, you now understand that a net is unfolding a figure, taking all the sides and folding it outward and seeing what that would look like. You do have an IXL assignment on that as well, and you have the 2 videos to watch, okay? So you're matching up, which one could it be? So one is with C, yeah? So this, if you unfold it, will make this net. This is called the net, this is called the solid. Three-dimensional figure. This little thing will be A, and this is you look at the base, it's a triangle, the base, and then all the sides are triangles, so it's B. Here the base is a rectangle. So that would be this, no, yeah, it probably would be this one. And here the base is a 1, 2, 3, 4, 5, and a hexagon, 6-sided figure. Top and bottom are the same. That's called a prism. When top and bottom are the same, this is a prism because, I'll show you why. It's just sideways. Top and bottom are triangles. These thingies are those 2 triangles. So this is called a prism. This is not, because top and bottom don't have the same shape. So there you go. Okay, packaging designers use nets to design boxes. Very important in the industry. Packaging is a big thing. You want to get, first of all, the minimum space, the most product into the least amount of material, because it costs money for packaging. And you want to use less space on the grocery shelf, because space on the grocery shelf is money. Yeah, so you want to make sure your product has a lot of stuff in it, yet you're using very little packaging. So it's called maximizing. So that's a very good job to get into designing those. And they use nets to design boxes and other containers like this. Yeah. So what is the net for the figure below? Label the net with its dimensions. If you watched both videos, especially the second video, has a way to show you how you can unfold this and keep track of the dimensions. So I like starting with the base. That's a rectangle. So I'll draw the rectangle. So you're looking from it kind of sideways. Three-dimensional always makes it like a little, you're not looking at it straight, but when you make your net, you have to realize that this is a rectangle and this is 7 and this side is 4. So you have to label the sides. All right, now I'm going to fold down this side. That's another rectangle. So I'm taking this and folding it down, and I'm going to, and I know it's 10 centimeters, so it's really a lot longer than 7. So this is 10, this is the side here, but this part is still 4. And then on the other side, you can't all see it all. You fold that out, that's the same. (10 by 4). And then I have the front and the back. The front and the back are triangles. I'll just fold it out like toward me. So then that would be from here to here, coming out like that. And the back is also a triangle, and it's folding out backwards, so it'll be like that. I don't know how long this tilted side is. There's no indication how long this side is. They don't have any number there, so we don't need it. But this is 7, this is 4, this is 4, this is 10, this is 10. And that would be the net. Now, if you fold it back together, you're going to get this, it's a prism, because you can look at the two triangles. It's also a prism. The front and the back are the same. How, let's see what they want here. How can you see the net? Well, it's three-dimensional, and I started with the base. I said, start with base, the bottom usually. I start with the bottom, and then I fold all the sides out. And fold all sides out. Okay. All right, letter B. Is there another possible net for the figure in part A? If so, draw it. Yes, there's different ways to draw other nets. So let's start again with the base, and I'm just going to fold out the sides again. So my base is a 7 by 4. And I'm still going to fold out those sides. And that's a 10 by 4. But now I could take this front and this front right here and use this as my folding out edge. So in other words, I'm not folding it down. I'm folding it sideways, like a door. Open the tent flap, kind of like that, yeah? And so then it would be, it's going to be, this is weird, but it's going to be tilted like that. Kind of like this, I think. Yeah, this right here actually should be 7 then. And this is the 10, and we don't know. This is this edge right here is this edge, which I don't know the length of. And then if you fold it back up, this goes on top of that. And it's the same on the other side. So we got that thing going on. This is the 7. And this is the 10. And this is the side. We don't have the number 2. I think that's going to put back together like that. And next we're talking about isometric drawing. So this kind of graph paper is called isometric dot paper. You can download if you like these kind of drawings. An isometric drawing shows a corner view of a three-dimensional figure. Okay, it allows you to see the top. So you need to see the top, the front, and the side of the figure. So top, front, side. So you don't see the back because it's hidden from view, right? You can only, so you're turning it. This is a filing cabinet, by the way. So you're kind of turning it sideways. And the isometric paper is really good to do that. So we're going to copy this shape. These are all squares. It says here cube, so that tells me it's a square. We're going to put this shape into this isometric dot paper. And what I'm going to do is for each side length, I'm going to use two dots instead of one. You could do one, but I want it to be a little bit bigger. So I'm going to start up here. And let's say I go from here to here, that's this side. And then over. And like I said, I'm always doing two. So that's this. And then I'm going to finish this like that. So that's my top, right? And then I have to draw down. That's this side. And then down here. And this side. And then I can close it. So that's the top cube, all finished. Looks about right. And then I'm going to continue from here. I'll go 2, down 2, and so on and so forth. You get the idea. I'm just going to finish this quietly. There, second cube. And then last. You want to make sure all the edges are covered, right? Now I'm stuck because I did it all at once. It might help to do one at a time, one stroke. There you go. That's it. Looks good. Okay, that's called an isometric drawing. Remember, front, top, and side view. Okay, and then on top of that, we have what's called an orthographic drawing. So we're on page 435 on the top. An orthographic drawing is another way to represent a three-dimensional figure. An orthographic drawing shows three separate views: a top view, a front view, and a right side view. The key here is right side. So that's always weird. Why that? But they had to make a choice. So top, front, right side view. That's so when you look at this shape down here, orthographic drawing, what is an ortho? You have to imagine what you see when you look from the top. Yeah, so let's see if we can figure that out. You notice how many cubes do you have? 1, 2, 3. So when you look at the top, you're going to have a rectangle with 3 of those cubes, right? 1, 2, 3. That's the top. But now we have this little thing hanging to the side. You see that on the top too. I think that's all you see when you look down. You won't see anything underneath. So there's the top, the front. So again, I have to look, how many cubes do I have? 1, 2, and then I'll see that and that. So I have this 2 plus that one. That's another rectangle with 3 cubes. So those are that, that, and that. And then I have that little thing hanging on the side, but it's on the bottom, right? Because it's down here, it's level with this one. There's that one. And then we have right side. So the right side is from the back, because right, you have to know what right and left is. So if you stand right here, that's you, and you look at that, this would be the right side. Looking at it from here, right? This is your left side. So if you look at it from here, what do you see? You've got this part right here, and then this up here. So you would see this, 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 this. So how does that look? So the bottom is a 2 by 1, 2, 3, a 2 by 3 rectangle. So then that's that rectangle right here, this whole thing. But then you have that little thing stuck on top, and it'll be right here. There, that's it. Top, front, right side, orthographic drawing. And I think that's already it for our lesson. And you are going to do lesson check for page 436. You're going to do number 10. Hope I recorded this. Yeah. Number 10, you're going to make a net and then label the net with the dimensions. It's just like the first question right here. Yeah, this is it. Usually you can match up the problems in order that I show them to you in the lesson, and refer back to the first example would be probably the first question on the homework. Okay, so what I need to see here is a net, and the numbers have to be correct. The second question is number 11. You're going to make an isometric drawing of this shape in here. Okay, look in the example again. And then you can skip number 12. I found that a little too weird. And you're going to the next page, 13. On the top, you're going to decide which of these drawings is isometric, orthographic, a net, or none. So you have to write next to it, what is it? What is it? What is it? What is it? So there's that choice. You got 4 choices. And then on the next page, 439, these are all easy problems. I find them. I don't know, you might have a hard time with that three-dimensional stuff. Now see, you have packaging. There's a hamburger box. There's something maybe like chocolate, and there's Chinese food container, right? You're going to match up which of these containers, which net goes with one. Yeah, which one is what net? Okay. And then 22 is an error. You have to decide who is correct. Is it Michaela or Gina? They made an orthographic drawing of this shape over here. One of them is correct, one of them isn't. And then you're going to make an orthographic drawing of 23. Remember, it's top, front, right side view. That's an orthographic drawing, and that's it. All right, good luck, you guys. I'll see you soon.